Today, I'm going to show you how to use Rive to create a really cool hero section for your portfolio site so you can now add interaction design to your resume. Let's get into it. So I'm in Figma, and this is the design that we're going to recreate. Now, first, I want to just talk a little bit about how to think about projects like this. Not everything on the screen is actually going to be delivered using Rive. For example, the navigation up at the top of the design, this is probably going to be built actually using Webflow or Framer or whichever website builder you're using. And this headline type here, this might also be better handled by the website builder instead of using Rive to do it. But all of this stuff down here is going to be built using Rive. Now, for this video, I'm going to show you how to set up all the animations and the interactions. You're going to learn a lot of really cool intermediate Rive tricks in this video, but I'm not going to walk you through every single step all the way through implementation in, say, a Framer site. If you do want to really dive deep into Rive, I recommend checking out Rive Academy Volume 1 and Volume 2, available on our All Access platform. The link will be in the description. So here's my vision. My vision is I've got this pixel art version of me. You can see I've kind of gone with a little bit of a 8 or 16-bit theme here. And what I'd like to have happen is when the user is on my portfolio site and I'm moving the mouse around, I want this character to actually look at the mouse and track it and follow it around the screen. I'd also like some interesting little Easter eggs if the user decides to click, say, my head or my stomach, something like that. And then I was also thinking that these app icons could be doing something kind of subtle just to reinforce the interactivity. Now, I want to stress, if you wanted to try and do something like this using Lottie, it would be very, very difficult, because once we get into Rive, you'll see that there's actually quite a bit of complexity here, and there's some tools in Rive that make this sort of thing a lot easier to not just build, but to also control and really nuance and finesse. Now, the first step is going to be to create the artwork for this, and so let me show you how I did that. So I'll show you what I tried first. So this is a Photoshop file that I was building. And basically what I did was I took some video of myself standing in my office and I just turned my head in all of the directions that I thought I would need. I also made a couple of silly poses like this, thinking, okay, if you click my stomach, I can act like you just punched me in the stomach. And if you click my head, I can act like you punched me in the face and I'm being kind of thrown back. And I thought that probably the easiest thing to do would be to use just some basic Photoshop techniques to turn this into pixel art. Now, this is not a design tutorial, so I'm going to kind of really quickly breeze through this stuff. But if you have any questions about this, how I executed this artwork, please leave a comment below and our team will check on those and make sure that we get them answered. So after doing a lot of processing, like posterizing all of the images and making the resolution smaller and then bringing it back up to pixelate it kind of naturally, doing a little bit of cleanup, this is what I ended up with. I ended up putting this silly eyeglass image over my face just because the eyes weren't really reading very well, and I thought that this kind of looked sillier anyway. So this is what I ended up with, and to be honest, I wasn't very happy with it. It doesn't look like an 8-bit character. It just looks like I've kind of messed with some video frames. Now, I did actually build this in Rive just to kind of see what it would look like. And it's cute, you know, like it's kind of fun to play with, but I really just don't like the look of it. I feel like the way that the character looks just looks like really kind of poorly manipulated still frames. It doesn't actually look like pixel art. So I decided to try a different method. So the way I looked at this was there's basically two ways I could have made the pixel art. So the first way would be to take the existing video frames that I'd kind of broken out and created and then actually just kind of manually make the pixel art. I could have traced over the images and tried to come up with something that looked good. The problem is it's actually pretty tricky to make pixel art. It's a style that takes a while to get the hang of. I'm definitely not good at it. And I knew it was gonna take a really long time. So the other thing I really wanted to try was using an AI tool to basically style transfer a pixel art style onto the images that I shot. And it turns out that was way harder than I thought. I tried a bunch of tools. I tried Midjourney, I tried ChatGPT, I tried Krea, I tried Magnific, and none of them could really do it. You can see some of the absolutely horrifying results here. Some of these, I mean, they're kind of fun in their own way, and maybe that's a different style to lean into, the crappy AI weirdness. But I did a lot of generations. Let me just kind of scroll through so you can get a sense of just how hard you have to work, even if you're using an AI tool like Midjourney to get the result you want. I tried different prompts. I tried using different features. I tried using images of me as a reference, and none of them were really giving me anything like what I wanted. I mean, come on, look at this thing. I don't know, I kind of love it actually, but it doesn't work for my design. Eventually, after a lot of trial and error, I started to get closer to the result I was after, but you kept getting these really horrifying generations that, I don't know, it just looks like somebody made out of Play-Doh and their face is melting. And so in the end, what seemed to work the best was using this image of me as an image reference and then just working on a prompt. After a lot of generations, I ended up with some that kind of worked, and this was my favorite. This one kind of resembles me. It has jeans and a black t-shirt like I was wearing, and this actually looks like pixel art. This looks like a video game character. Okay, so now I have one image after like hundreds of generations that I think can work, but now I need that same character to be looking in different directions and to be doing different actions, and I need those images as well. And so I thought that, well, okay, now that I've got one image I like, this part should be pretty easy. Well, I was wrong. It was actually almost impossible to get Midjourney to generate all of the different head angles and the actions. I was literally feeding it my Photoshop sprite sheet with the copies of me on there, and it just kept messing them up and making them look terrible. So I had to figure out how to take that image and get variations of it while keeping that character very, very consistent. And luckily, I figured out that there's actually kind of a hacky way to do this. And here is the hack. Midjourney now has built-in video generation. And so I could feed it that still that I liked, and I could ask for things like turntables, so I could get different head angles. Now, you'll notice that Midjourney, in some cases, it thought that I might be hiding a ponytail behind my shaved head. For the record, do not have a ponytail. But once I figured this out, I realized that if I generated enough videos, I could probably grab one frame here and there to get what I needed, and then use Photoshop to bash everything together. And so you can see some of these generations work better than others, but really all I was looking for was one or two frames with different body positions and different head angles and some different faces. And I ended up generating a lot of these. Most of them were pretty useless. Sometimes a dog would enter the frame. I had to basically figure out how to trick Midjourney so that the character would look up and look down. And it took a long time. Actually, it wasn't very straightforward to get this result. And I want to show you this because I thought that this was an interesting example of how you can use AI to help you get closer to your vision. And without a tool like Midjourney, I could have still done this. It would have just taken much, much longer. Maybe it wouldn't have come out as good. But even using AI, it was a crazy amount of work. You still have to know how the tool works. You have to know the limitations. I kept bumping into them and having to find workarounds. And in the end, I finally had enough video clips to go through and pull the frames I wanted. And then it was time to go into Photoshop. And this is where I ended up in Photoshop. So I have my base body here. This is the pose that the character is going to have most of the time while the head is kind of looking around and following the mouse. And then I thought, okay, if I punch the character in the face, this is kind of a good pose for that. And if I punch the character in the stomach or I click on the stomach, this would be kind of a funny pose too. I should note that this head came from one video, this body came from a different video, and the fists came from yet a different video because they were actually getting cropped. Same thing with this pose. These wrists had to be basically recreated, and I actually had to go in and hand paint sort of a pixely texture. Now, one thing about using Midjourney, or really any AI, is it's not actually creating pixel art. You can see that this kind of resembles pixel art. When you just glance at it, it works. It does look like a video game character. But if you look closely, these aren't actually pixels. There's not actually a consistent pixel grid here. And so this isn't totally accurate. So if I wanted to spend a lot more time on this and I really wanted these to look like pixel art, what I would then need to do is take all of the frames that I bashed together in Photoshop, bring them into a new Photoshop document that has probably low resolution, turn on a pixel grid, and literally trace them to get that true video game pixel art look. And that would be really, really cool. It would also take a lot of time. So again, this is just to point out that AI really, at this point, and in my opinion for the foreseeable future, it is just a tool, and there is a lot of gotchas and a lot of hangups, and you have to do a lot of work to overcome them. And the work you have to do actually requires you to be good at things like Photoshop and other tools like that. But for our purposes, this is going to work just fine. So I've got these two poses, which basically live all by themselves. This is the primary pose, and this is the main head that's kind of looking right at the user. When the mouse is right in front of the face, this is what you're going to see. But I needed a bunch of different heads, and I cut those heads out of a bunch of different video generations. I would literally scroll frame by frame through them to find the right head. So if I turn off the head, which is this layer, first of all, I want to point out that I've layered this thing out. So I cut the arms out, and filled in the body behind. So I could actually move those arms separately. I also separated the top of the body and the bottom of the body, so I had some more control. And then there was one other layer I had to add, and let me show you why. So if I turn on, say, this head layer where I'm looking down and to the left, I'm gonna turn off this head backer layer, and you're gonna see that there's now a hole there. And so I needed a layer, and it just looks like this. I'll solo it for a minute. It's just this little scribble I made to basically fill in any holes, because these heads that I've cut out and placed on this body, they weren't originally on that body, and the body was in a different position. And so I needed to make sure that they at least stuck to the head. I found that some of the heads worked best when they were kind of on top of the body, on top of everything. But then other heads, like this one, they worked better when they were layered between the body and that head backing layer. So in the end, I had to create all of these head layers. I had to make sure that I had them looking to the left, looking up, looking down. One good thing was I didn't need to have it look both to the left and to the right, because I can just duplicate this in Rive and scale it negative 100% on the x-axis, and now the character is looking to the right. And this is actually something that's pretty important when you're working with Rive files, because this Rive file is going to be hosted by a website builder, and when the user goes to your site, this is going to have to download to their browser before it can start playing. And so you want to be very, very careful with file size. You want to do everything in your power to make sure that you're optimizing your Rive file. And so one of the ways you can do that is by recognizing, okay, if the character is looking to the left, I can flip that image and now the character is looking to the right. So I don't need two images to do that. I just need one. That's gonna save space and save bandwidth. So setting all of this up, cleaning things up, I mean, there was a lot of cleanup, a lot of manual paint to make these things work. It took a couple of hours just to do this step. So again, I'll say it one last time, AI is not gonna do much for you. But I am pretty happy with the way this is looking. I've got everything layered up. I've got a nice Photoshop file here, and I can import this directly into Rive. So I'm just gonna turn all the layers on so you can kind of see all of the heads and the bodies and how everything's set up. And now let's talk about bringing this into Rive. If we look at this Figma file, I can see here, this is the size that the character is going to be in the end. And so if I click on the character and I come over here to the layout, I can see that we have a resolution of 322 by 883. So I only need 883 pixels of vertical resolution for this character. But back in Photoshop, if I hit Command-Option-I to open up my image size dialog here, you can see that it's quite a bit taller than that. And so if I import this into Rive, it'll work just fine, but it's gonna be taking up more memory than I need it to, okay? So I'm gonna save a copy of this first, and we can just save this as Joey main small. And then I'm just gonna go ahead and resize it to 883 pixels tall, like this. And to try and keep those edges as crisp as possible, check out this setting. This is the resample. By default, it's usually gonna be in automatic mode, and Photoshop's gonna analyze the image and decide which algorithm to use. But in this case, I wanna use nearest neighbor hard edges. And what this is gonna do is it's gonna prevent Photoshop from trying to anti-alias my edges for me, which would make them kind of smoother looking, and it should keep the edges a little crisper. So let's hit OK. And then we can kind of zoom in and we can see, and it's funny because this actually makes it look a little bit more 16-bit or 8-bit because it kind of crisped up the edges a little bit for us. So now this is good to go. We can save it and we can head into Rive. Now in Rive, I've already set up an artboard that matches the size of my artboard in Figma. I've imported the font that I use so I can use it inside of Rive. And by the way, if you import a font into Rive, that is going to increase the size of the Rive file if you're embedding it in the Rive file. You can also host the font file separate and load it externally. A little more technical to do that. So I usually just embed it in the Rive file, but that is gonna make the size a little bit bigger. And so I might, in the end, turn off the type if I was gonna export this for real, because this type and the navigation and everything would probably actually be created in Framer or Webflow or a tool like that versus doing it in Rive. That's gonna make it a lot easier to change in the future. But just so we can see what our design looks like, I have this all set up, and now it's time to work on the Joey character. So in my Assets tab here, I'm gonna import that Photoshop file. So you just click the plus, click Upload, navigate to the folder where you saved it, and there's my Photoshop file. And you can see it's 3.2 megabytes. That's pretty big. But there is an amazing feature in Rive that I'll show you in a second. So when you've imported any kind of raster artwork, it's gonna automatically process it. And you can change the settings on this anytime you want to, but if I click on this layer here, you'll see that there's a compression setting over here in the properties panel. And by default, it's going to use the WebP format. It's basically going to recompress your image for you from PNG or a Photoshop file to WebP, which is a relatively new file format that supports transparency and gives you a ton of compression while keeping a lot of quality. So the default settings are usually good enough. And if you export your Rive file and it doesn't look great, you can just select all of your layers and you can change the quality and increase it if you need to. So now that I've got my Photoshop file imported and you can see I've got all the layers, I'm just gonna drag this onto my canvas and you can see it comes in and it looks exactly like it did in Photoshop. And if I open up this main group, you'll see I have all of my layers ready to animate. So what I wanna do is create a new artboard that's just going to contain Joey. So I'm gonna grab my artboard tool up here and I'm just gonna quickly drag something that's about the same height. Then I'm gonna check the height. This is 883 pixels, so I wanna make sure that this is the same height, and then I can kind of line it up like that, and now we're ready to go. Let me make the background white. It'll be a little bit easier to see while we're working, and then we'll get rid of the background when we're ready. I can also rename this artboard Joey. All right, so here's what I'm trying to do. I want to take this character who's kind of sitting like this, and I want a little bit of an idle animation. I want the character basically just to be sitting there breathing, essentially. You see this a lot in fighting games where you're selecting your character or something like that. So let's start by animating that. Then we're gonna bring in all of the different heads and we're gonna set up the interactivity for that. So I wanna make sure I'm in design mode. If you see a state machine or a timeline down here, you are in animate mode. And in Rive, these two modes behave a little bit differently. So I wanna be in design mode when I'm setting up the initial state of my animation. So I can come into this artboard and I'm gonna grab all of the layers that represent body parts. And right now it's actually a little bit tough to tell just at a glance which ones are heads and which ones are body parts. So what I'm gonna do is I'm gonna select everything that has the name head at the beginning of it, because then I know that these are all the heads I'm gonna be using. And then I can right click and I can say add a tag, and I already have some tags set up for this project, but I'm gonna show you how to make a tag just in case you don't know. So if you click new tag, you'll see that now all of these have this little icon next to it. It's just a nice visual organization feature, but I don't want it called tag 4. So I have to make sure nothing is selected. You can just click anywhere in the canvas and here are your tags. And so I could call this heads and I could give it a new color. I don't know, why don't we make them bright green or something? And now all of my head layers have this nice green tag, easy organization. So I'm gonna need my arms layer, the top, the bottom, the head backer. I'm gonna copy these and then I'm gonna go into this artboard and paste them. And that can just kind of center this up a little bit, okay? Cool. Now I need a head. So let me just go ahead and grab the default head. I did not a great job of labeling these, but basically if it's looking down, it starts with a D, up starts with a U. If it's in the middle, it's gonna start with an M, and this MC is middle center. So let me copy that one and paste it in here. And this head goes underneath the top layer like this. So let me move that over, move that into position. And there we go, that's good to go. Okay, so now we can set up some basic animation. We can set up a simple idle animation here. So to do that, I'm gonna hit tab to go into animation mode, and I'm gonna change the name of this timeline to idle. I'm gonna grab all of the layers that I know I'm gonna wanna animate. So the arms, the top, the head is gonna move. And the head backer, that's that layer that's just behind to kind of fill in any gaps when we swap out heads. That's also gonna move, but I think it's gonna be easier to basically just parent that to the top layer. So I'm gonna show you a trick to do that once I get the initial animation set up here. But first, with these 3 layers selected, I'm just gonna put a keyframe on Y position, and I wanna set up my timeline a little differently here. I wanna give myself some more time to play with here. So I'm gonna make this timeline 4 seconds in duration. And then I want to set the snap keys to 12 frames per second. And the reason for that is I also want to activate this quantize feature. And so what this does is it's now basically setting the frame rate of this timeline. If I set snap keys to 12 frames per second, that means I can only set keyframes in increments of 12 keys per second. But when it plays back, it's actually going to play back much faster than that. But if I turn on quantize, I will now get that low frame rate look, which I think could be cool for this. I'm gonna grab this blue handle so I can zoom out and see my whole timeline. So now I'll jump forward to some arbitrary time. I know I'm gonna have to play with the timing, so I don't know exactly how fast this should happen. But the arms, the top, and the head, they're all gonna move up, and that's kind of what happens when you breathe. You sort of stretch out vertically, and your arms, which are leaning on your chest, are gonna move up because your chest moves up, okay? So I'm gonna select all 3 of these layers, and I'm gonna hold Shift and bump them all up 10 pixels. Then I'm gonna grab the arms layer, I'm gonna bump that up maybe another 5 or 6 pixels. And then for the head, I think that can probably actually raise a little bit less. So I'm gonna lower that a few pixels, like that. So now you get something like this. It's subtle, but you can see that if I kind of scrub back and forth, it looks like I'm breathing. Sometimes it doesn't take a lot to get a nice little animation. So let's figure out the timing of this. So this is 10 frames. Let's jump forward another 10 frames here. It looks like right about there. I'm just gonna copy and paste these keyframes. And I wanna make sure that this is perfectly evenly spaced out. There we go. And so now if I play this, the animation's kind of boring because these are linear keyframes. Just like After Effects by default, Rive is gonna apply linear easing to everything. And I want something a little more like this. So I'm gonna go into the interpolation menu with all my keyframes selected, and I'm just gonna add a little bit more of an ease in and an ease out. And now we can see this looks a lot more natural, and I like the little stuttery frame rate thing. I think that's pretty cool too. So the next thing I wanna do is add a little bit of follow through. It'll just make it feel a little bit more natural. So I'm just gonna grab all of these keyframes, copy and paste them one time. And you need to do this so that you have a little bit of heads and tails on your animation. We're gonna make this loop, but in order to add follow through with a loop, you're gonna need at least 2 copies of your keyframes. You'll see why in a minute. So right now, everything is moving up and down at exactly the same time. But if I think about how this would actually happen, I feel like the arms would probably lag a little bit behind the body. So maybe I'll move that forward a frame. And then the head would also lag a little bit behind the body, maybe 1 frame. So now when I play this, it's very subtle, but you get a little bit of that follow through with the arms and the head. So now if I wanted to loop this, I cannot start the loop here because there's no animation happening on the incoming side of this. So what I need to do is move forward to where there is animation, and I basically want to chop this timeline so that it contains exactly 1 loop's worth of animation. There's a cool feature in Rive to let you do this. So I'm going to click on this icon here, and the first thing I'm going to do is set my timeline to loop, and then I'm going to turn on the work area, and you're going to get another set of blue handles here. And what these do is this tells Rive which part of the timeline to loop. And the rest of the timeline will not play. When you play this timeline, only what's within these blue handles will play. So if I set up a perfect loop like this, right? It starts on this keyframe and it ends on the same keyframe. When I now play this, you can see that the timeline indicator just loops between that area, and we've got a seamless idle loop for our character. Now, I mentioned that this head backer layer is not actually moving. There's no keyframes on it, and I do need it to move the exact same way that this top layer is moving. So an easy way to do that is with constraints. And this is going to be an easy way to use constraints. I'm going to show you some more advanced stuff later in this video. But if I take this layer, this head backer, and just to remind you, this is what it looks like. It's just a black paintbrush I used in Photoshop to fill in any gaps when the heads change shape. But I'm going to add a constraint to it, and I'm going to use the translation constraint. What this constraint does is it essentially parents one layer to another, but it only looks at the position, not the scale or rotation. And in this case, that's all I need. I just need position. So I need to go into the settings for it and tell it which layer is the target, which layer is it attached to. And I want to attach it to the top layer. Now you'll see that it moved it down here because it moved it to the anchor point of the top layer, and that's not what I want. So I'm gonna undo this for a minute, and before I select the target, I'm gonna turn on the offset property. And now when I target the top layer, this layer won't move. It will calculate the offset that's necessary so that it's parented, but it stays in its original position. If I go back into my timeline now, you'll see that now that head backer layer is moving perfectly, and so when I change the heads out, we're not gonna get any weird gaps. Cool, so now we have the animation set up for one of the heads, but we've got 8 other heads, and it's gonna be kind of a pain to have to animate that same thing 8 more times. There is a better way, and in fact, we're gonna have to set this up a little bit differently in order to make it easy for the mouse to dictate which head we're seeing. So I'm gonna hit tab to go back into design mode, and we're gonna organize this a little bit differently now. So this head is just one head layer. This is the middle center head. But I know that I'm gonna be swapping out a lot of different heads here. I'm gonna have 9 in total. And since these heads aren't gonna be animated, you're not gonna see the turn. We're just gonna basically turn one layer off and turn another one on. Basically, I need a way of easily telling Rive which head I'm supposed to be seeing. And there's a great feature that does this automatically called Solo. So I'm gonna right-click my head, and I'm gonna say wrap in a solo. Now, what does a solo do? Well, to demonstrate, let me pull in the rest of the heads here. So I'm going to grab all of the heads that I don't currently have in there. So it's these 5 heads. I'm going to copy them. Then I'm going to go back into my Joey artboard and paste them. And I'm going to drag them into the solo. A solo is like a group. You can group things underneath it. But the cool thing is you've got this little radio button here. And when you click it, this tells Rive which head you're supposed to be seeing at any given time. And what's really cool about this is it doesn't just show you the image that is selected, it also saves the position scale and rotation of that image plus any other settings that you have on it. So this head is looking down and to the left. Let's move it into position there. But you'll see there's a problem. The problem is that because this solo layer is below the top layer, we're seeing this little bit of shirt over the face. I realized this when I was setting all of this up in Photoshop, that some of the heads work best when their layer is underneath the shirt. But then some, especially the one where the character is looking down, well, now the head is coming over the top of the shirt. So the layer order actually has to change depending on which head is being seen. And that can get really, really squirrely. Fortunately, the solo feature in Rive, it can remember everything about the layer that you're turning on, including its draw order. So I'm going to show you a feature in Rive that does not exist in After Effects, and it is super handy for stuff like this. And it's called draw order. So by default, the draw order works just like After Effects. Things that are on the top of your hierarchy are drawn on top of everything underneath it. It's pretty intuitive. But in this case, I actually want this layer drawn on top of this top layer. So with this layer selected, I can come over here and click on draw order, and right now it's using the normal draw order rule, which works the way I just explained, but I can now set a different one. I'm going to call this one over, and I'm going to activate it. And then I'm going to go into the settings for it, and you can see here it's saying this is the name of the draw order. It's going to draw above the target, and the target I want it to draw above is this layer. And so now, even though in the hierarchy, this head is below this layer, it's actually drawn on top of it. So now it looks correct. And what's cool is this layer, which looks better when it's still underneath this, well, this is using the normal default draw order, so it's underneath. This one's on top. And I don't have to do anything once this is set up. Just by choosing the right solo, I now have the right settings set up. Now, this head is looking down and to the left. I'm also going to need one that's looking down and to the right. So what I can do is just hit Command D to duplicate this layer. Let me turn on the duplicate, and let's rename this DR. And then I can come over to Scale, and I can set the X scale to -100. So now it's flipped around. And then I can just move this over, and I may have to move it down a little bit until it looks right. And that looks pretty good. And then I can see if it works better with a normal draw order or the over draw order, and clearly the over draw order works best here. So now I've got 3 of these heads set up, and you can see they all have the correct position and the correct draw order, and all I have to do is select in the solo which one I'm seeing. I'm going to quickly go through and set up the rest of the heads. I'll scale the ones that need to be flipped. I'll make sure the draw order is correct, and I'll be right back. All right, so now I've got all of these heads set up, and you can see just by kind of clicking through, you can already kind of sense the way that this is going to animate. And I've got the draw order set up. We may need to tweak some of these positions once we actually see it moving, but for now, this is good. Okay, so now we've got a little bit of redoing that we have to do because I have animation on this head layer. But you'll see when a different head is soloed, we don't see the animation. That's because the animation is on this head MC layer, which is not currently visible. So what I need to do is just transfer that same animation onto the solo. So now all of these heads will move the exact same way. So what I'm going to do is I'm just going to go to the first frame where there's a keyframe for the head, and I'm going to put a Y keyframe on the solo layer, just like that. And then I'm going to copy all of the keyframes from the head MC layer and paste them onto the solo. So now we have the same animation. And now you can see we're good to go. Then I can delete this head MC animation. We don't need it anymore. What's really cool about this, if I run the state machine so I'm not accidentally changing keyframes in the idle timeline, I can run the state machine, and on the fly, I can change the heads, and you'll see they're all moving the exact same way. So that idle animation now applies to all of our heads automatically with one set of keyframes on the solo. That's pretty cool. All right, we're making some good progress now. So now we need to figure out, first of all, how do we know where the user's mouse is? How do we even track that? Then we're gonna have to figure out how to take that information and let that dictate which head we're seeing, okay? It's actually a lot easier than I thought it would be because Rive has some really cool built-in tools like Joysticks, which I'll show you in a minute. But first, how do we track the user's mouse? So let's go back into design mode. And I'm gonna need a little more room here. So I'm gonna move this over here so I have some more room. And I'm gonna move it down quite a bit. So I'm gonna introduce you to a concept that if you're used to working in After Effects, this is gonna be unfamiliar. This is not something that exists in After Effects. It's called a hitbox. So let me show you what I mean. I'm just gonna grab my rectangle tool up here and I'm gonna draw a big rectangle, something like this. Now, why did I draw it so big? Let me first select the rectangle and delete the fill on it so it's invisible. Now, this rectangle is still there. It's very important to note that this technique I'm gonna show you, it only works if this rectangle or whatever shape you're using has opacity. So you'll notice that there's still 100% opacity on this layer, but there's no fill or stroke on it. So there's no pixels to display. But this technique will not work if I set this to 0. It does need to be 100%. So I've got this rectangle here, and I'm gonna rename this hitbox. And just to make it a little bit easier to find when I glance over at the hierarchy, I'm gonna add my hitbox tag that I've already added. Now, I made this hitbox really big because this is the area that will be able to track the user's mouse. And I wanted to at least encompass the artboard that is gonna be where the hero section is, okay? We're gonna start doing some fancy stuff a little bit later in this video, but to start, I just wanna make sure it's big enough to at least fill up the vertical space here, right? So if we remember, this is 852 pixels tall, so I'm gonna make sure that that rectangle is at least 852 pixels tall, and it probably needs to be a little bit bigger, actually, because we don't actually see the character's feet in the end in the designs. I might stretch it out even more. It doesn't really matter how big this is. It just needs to be big enough. I'm gonna center it, then I'm gonna lock it so I don't accidentally select it and move it around, okay? So here's my hitbox. Now, what is that hitbox for? In Rive, if you want to track the user's mouse, you need a layer that defines the area in which you're tracking the mouse. So that's what a hitbox does. Now, to make it actually track the mouse, I'm gonna need another layer, and I usually just make a little small circle like this. It could be any color you want, and I'm just gonna call this mouse tracker. This is the layer that will actually move to where the user's mouse is, and then you can do things based on that layer's position. So let me add the mouse anchors tag to this. And then I'm gonna hit tab to go into animate mode. And this is gonna be done using a listener. So a listener turns a layer into something that is listening for user input. I'm moving very quickly through these concepts, by the way, and if you're trying to wrap your head around the way Rive works and the way the state machine works, I highly recommend you check out Rive Academy Volume 1 on our All Access platform. That course will get you up to speed very quickly with how all of this works, and Volume 2 gets into some really advanced things, kind of like we're doing here, but in even more detail. So with the hitbox selected, I'm gonna hit plus to turn it into a listener. And I like to label my listeners based on what they're listening for. So this is listening for the mouse move event. And then I can come over here to the settings and tell the hitbox what it's listening for. So it's not listening for pointer enter, which is when the mouse enters it, when it kind of crosses the boundary into it. It's literally listening for any time the mouse is moving inside of it, okay? Now, when it detects that, what should it do? So I'm gonna come down here. This is the section where you tell Rive what to do if something happens, okay? So by default, it's got this behavior which isn't doing anything, so I can get rid of it. And I'm gonna add a new behavior called align target. Align target will move a layer to wherever the mouse is. So I'm gonna click on target, I'm gonna pick the mouse tracker layer, and now if I run this state machine, you'll see that that layer follows my mouse around, okay? So now I can do things based on the position of the mouse tracker. There are a lot of ways to handle mouse tracking in Rive. This is the simplest way, unfortunately for us. In this example, it's gonna work just fine. All right, now for the fun part. How do we tell Rive which face to show? So to do that, we're gonna use a very nifty feature called Joystick. So to demonstrate that, let me come up here to this menu, and I'm gonna grab a joystick, and I'm just gonna click here to add the joystick. What a joystick does is it gives you a control, it gives you a handle on the joystick, and you can move this around. And then, as you can see over here in the controls for it, it takes in two arguments, two timelines actually, one for the x-axis and one for the y-axis. And you don't have to have an x and a y timeline. You can have just one or you can have both. But depending on where this handle is, it will play that frame of the x-axis timeline. And if I move it up and down, it will play that frame of the y-axis timeline. So it will blend between two timelines in this really organic way. If you've used joysticks and sliders in After Effects, this works pretty much exactly the same way. It's super powerful, and it may not make a ton of sense until I actually build the thing and you see how it works. If you really want to deep dive into joysticks, check out Rive Academy Volume 2. So in order for this joystick to actually do anything, first we're gonna need two timelines. But even before we do that, I wanna make sure I have this sized correctly. So right now I want to point something out. If I zoom in and out of my canvas with the plus and minus keys, you'll notice the joystick stays exactly the same size. It's not changing at all, right? Visually, it stays the same size. Sometimes this is useful. This is useful when you, the animator, want to control what this joystick is doing. But in this case, that's not what I want. I want the user to control what the joystick is doing through their mouse movements. And so in this case, I'm gonna need to turn on Draw in World Space. So now the joystick will basically maintain its relative size to this. That's really important because if I'm playing my state machine and moving the mouse around, and eventually that's gonna be controlling this joystick handle, if the joystick is changing its size based on the size of the canvas, that could throw off the coordinates. So I need it to draw in world space to basically always be exactly the same size relative to the mouse movement. I hope that makes sense. It's kind of a tricky concept to explain, but if you just play around with it and zoom in and out of the canvas, it'll become obvious to you what it's doing. So it's important to note that this joystick handle cannot leave the boundaries of the joystick, okay? And essentially, sneak peek, what I'm gonna be doing is mapping the timeline so that when the handle is here, the character is looking up and to the left. And when it's over here, it's down and to the right. And when it's in the middle, he's looking right at you. This is going to dictate which frame we're seeing. And so the mouse is gonna be moving all over the place, right? So I need this joystick to be at least big enough to give me room around the head to be able to track the mouse pointer accurately. So I'm just gonna make this big enough where it's basically gonna cover up his head and give me a little bit more room. So I can lock the X and Y axis here and just scale this thing up, and something like that is probably gonna work fine. Now I can move it off to the side. In order to do this, we're gonna have to tweak our solo a little bit. So let me rename this solo Heads, because this contains all the heads. Now, in order to make this really easy, I'm gonna teach you a trick called nested solos. This is really, really cool. Basically, you can have solos inside of other solos. So let me try to walk you, this is gonna be kind of difficult to explain. Let me try to walk you through why I'm doing it this way. If you imagine the joystick handle is up here, then I know in my y-axis timeline, I basically want all of the heads that are looking up. And when the joystick handle's down here, I only want heads that are looking down. But then it could be looking left, it could be looking down the center or down and to the right. And so I've basically got three groups here. I've got heads that are looking up, heads that are level, and heads that are looking down. And then within that, I have a head looking left, a head looking straight at you, and a head looking to the right. And so what I actually want to do is I want to be able to turn on the heads that are looking up, and then only switch between those. Then turn on the heads that are looking kind of straight, level like this, and then pick between left, center, right. And I basically want these groups of heads, but I want them organized by what vertical direction the head is looking. Hopefully that makes sense. So inside of the solos, let me just group these really quickly. So we've got down and to the right, down and to the left, down and to the middle. I'm gonna select all three of these, and I'm gonna right click, and I'm gonna wrap these in a solo, and I'm gonna call this down. Then I've got my middle center head here. I can turn that on just so you can see it. And that's gonna be paired up with middle right, middle center, middle left. So I'll select all three of these, and I'm gonna wrap those in a solo. And these, I can just say middle. And then the rest of the heads, these are all the heads that are looking up. So I'm gonna select those, and I'm gonna wrap those in a solo, and I'm gonna call this up. So now I've got three solos inside of the main heads solo. So now I can pick which group of heads I'm looking at based on the Y position of this joystick. So let's actually put this into practice. I'm gonna make a new folder down here in my animation section, and I'm gonna call this Joystick, just so I can be organized. Inside of that, I'm gonna make a timeline, and this one is going to be the Y axis. So the way joysticks work is if you're moving the joystick handle on the X axis, when it's all the way to the left, it's correlated to the beginning of your timeline. And when it's all the way to the right, it's correlated to the end of your timeline. And when you're moving it vertically, the top is correlated to the beginning of your timeline and the bottom is correlated to the end. And if you get that backwards, it's not a problem. You can reverse the direction in the joystick settings, but it's good to just kind of wrap your head around that before you get started. So we're working on the y-axis timeline, which is going to control the vertical direction the head is looking, okay? So if this is all the way at the top, that correlates to the beginning of the timeline, which means that the head should be looking up. So what I want is this up solo selected, okay? Now you can see because I played with the joystick handle here, it set a keyframe for the joystick, so let me delete that. I don't need that. But when I changed the solo to the up group here, you can see that it actually set a keyframe. So now at the beginning of the timeline, that is the solo that is going to be selected in the main head's solo group. Now when I go to the end, I want the down group. And right in the middle here, I want the middle group. Okay, so now I have this very simple timeline where I'm basically just going between up, middle, down. That's the y-axis. Now let's deal with the x-axis. So I'm just going to duplicate this, and I'm going to call this timeline x-axis, and then I can just delete all these keyframes. Now, on the x-axis, now I care is the head looking to the left, to the middle, or to the right. And so what I need to do here is I actually need to set keyframes on all of these solo groups so that I'm looking at the right head at the right time. So remember, if the joystick is pulled to the left, that correlates to the beginning of the timeline. So the first keyframe should be heads looking left. So I'm going to click on the down to the left, middle left, and upper left. So I have keyframes for all three. So now no matter which group is being shown, down, middle, or up, we're always seeing the left looking head. Then in the middle, we can set the middle heads up. So up middle, middle center, and down middle. And then I'll go all the way to the end, and now the head should be looking to the right. So I can just click on the correct solos, and now our timelines are set up correctly, okay? There we go. So now we can actually connect these timelines to the joystick. So I'll go back into design mode, and I'm gonna say x-axis, use this timeline. So I maybe should have labeled it differently. Remember that the name of the timeline is x-axis and y-axis. So when I select the joystick, it's gonna show me all of the timelines attached to this artboard. So I've got the idle animation, which that's not what I want. I want the x-axis tied to x-axis and the y-axis tied to y-axis. And so now just to briefly demonstrate what this does, if I go back into animation mode and I go into the state machine and I just hit play and just run this, you can see where the joystick is. It's down and right in the center. And so that's the head we're seeing. Now I can't click and drag the joystick handle while the animation's playing. Unfortunately, that would be pretty nice if I could. But what I can do is select the joystick here and I can change the handle position. So if I pull this down, you can see that I actually can control the head. And if I pull the X position over or to the left, you can see I can also control the rotation from side to side. So, okay, it's working. We've got it working. So now how do we actually tie that to the mouse movement? So joysticks have a property called handle source, and you can basically click it and pick which layer it should be looking at to know where the joystick handle should be. And so I want it to follow the mouse tracker, but the problem is if the mouse tracker is right here, I don't want the joystick handle to try to end up there because it's gonna basically pull all the way to the left and get stuck here, and the head is gonna be looking left when the mouse is right in front of him. So what I actually need to have is a second mouse tracker that's offset from this one. And that's really easy to do. I'm just gonna duplicate my mouse tracker, and let me rename this mouse offset. And this mouse offset, I'm going to parent it inside of the mouse tracker, just dragging it right into that group. And then I can pull this over and I can line it up right with the center of the joystick, just like that. So now when this mouse tracker moves around, it's going to move this layer around, but it's aligned to the joystick. So what I can then do is click on the joystick and say the handle source is this mouse offset layer. Now, if I run the state machine, watch what happens. I'm tracking my mouse, and you can see that the joystick is basically mimicking what my mouse is doing, okay? Now, it looks like I've got a little bit of an issue here. When the mouse is over here, the head looks left, and then the head looks right. So I maybe had some layers mislabeled because the bottom one works perfectly. But this is gonna be really easy to fix. So I'm gonna go back into my x-axis timeline, and the up ones were the ones that were incorrect. So head up and to the left may literally just be labeled wrong here. So let me just change this to up and to the right. It could literally be that simple. I'll just flip-flop these keyframes. And now I'll go back into the state machine and play it, and now everything should be working correctly. Now, this is where you can really spend some time nuancing this if you want, okay? So right now, if I put my mouse here, the head is looking up, okay? And I want to have it basically not look up until the mouse is probably up here. So if you look over at the joystick, when my mouse is at the top of the character's head, it's about 3/4 of the way up the joystick, right? And now I want the head to look down. It's not looking down soon enough, really. So this is pretty easy to control, but it just takes a lot of experimentation, but I'll show you how it works. So in the y-axis timeline, what's happening is when the joystick is right in the middle, that's when it's gonna hit this keyframe. But I actually want it to hit this keyframe a little bit earlier. So I'm gonna move this way back here. Then I'm gonna copy and paste that keyframe so I have a copy of it, and I'm gonna try and create some symmetry here. So now I've got this huge space in the middle where I'm always gonna be seeing the middle head, right? Whereas before, there was only one keyframe, so you had this narrow area where the joystick would trigger that head. Now I can go back in the state machine, and I can see that now I get a lot more latitude before the head looks up or down. And I could do the same thing side to side, and you could really spend a lot of time nuancing this. You can go into the x-axis timeline and do the same thing, but it's actually working well enough for me, and I don't want you to sit here and watch me do something super boring. This is working pretty well, and notice that even as it's animating, the idle animation is still looping, and everything is working perfectly. There's a little bit more work I want to do on this to make it work even a little bit better, but I'm gonna take a detour and we're gonna work on the click animations for when you actually click on me and I get punched. I think that'll be a nice little palette cleanser. So if we come back over to the artboard that has our artwork on it, remember I've got these two bodies here that already have the heads attached, and I wanna show these when the user clicks on me. And if he clicks my stomach or torso, I wanna see this one. And if he clicks my head, I wanna see this one. So let me copy both of these. So I'm gonna grab the gut punch and the face punch layers. I'm gonna copy those. Then I'll bring those over to my Joey artboard and I can paste them right in. Let me move them up to the very top so I can see them, and let me just move them into position so they're pretty much lined up with the character. And it looks like my artboard might need to be a little bit wider. In actuality, it doesn't matter because Rive has a setting on every artboard. If I click on it, you can see right here, there's a clipping setting. And right now it's off. By default, it is. If I turn it on, it's gonna clip that character's arms. If I leave it on, it won't clip the character's arms. And so I can actually just leave the artboard this size and leave clipping off, and I'll have the exact same result when I nest this artboard later. Now let me grab this body and let's line that up. And so now we've got our gut punch and our face punch layers set up correctly. And by default, the visibility on those is gonna be off. So now I'm gonna go into animate mode, and we need to set up a timeline for what happens when Joey gets punched in the face. So I'm gonna say face punch, like this. And there's a few things that's gonna happen. I do wanna put a little bit of movement on this, but the main thing that needs to happen is, as soon as the user clicks my face, I need to hide all of the layers that are showing this version of me. So let me select the arms, the top, this head solo group, the bottom, and the head backer, and I'm just gonna set the opacity to 0. And then at the same time, let me turn on my face punch layer. I'm gonna make a keyframe here so that its opacity is 100%. And now we can put a little bit of animation on here. I wanna make sure my timeline settings are the same as the other timeline. So snap key set to 12 with quantize turned on. Let me make this a little bit longer. I'll make it 2 seconds so I've got some time to play with. And what I want to happen is, as soon as I get punched, I want this layer to scale down, like I've been knocked backwards a little bit. So I'm just gonna scale this down just a little bit. Maybe let's try 90%, that might be too much. And then it looks like I made this timeline way too long. I don't need 10 seconds, let's do 2 seconds. Maybe, I don't know, at 1 second, it's come back to its normal size. So I'll set this back to 100. And what I want to have happen is I want this to kind of spring back and forth, right? I think that'll look really cool and kind of quirky and video gamey. So right now, this is what that looks like. And that first keyframe does need to be 100%. So let me fix that really quickly. So I get knocked back, and then I come back forward like this. And I feel like that knocked back should probably just be 1 or 2 frames. It should be really fast. Yeah, 1 frame, and then I come forward. So in order to get a nice springy oscillation, if you've taken animation boot camp, you'll know what that means. In After Effects, you would normally either use a really elaborate expression or you would just manually keyframe this. But in Rive, you've got another option. You have a built-in elastic interpolation option. So you can select 2 keyframes, select elastic interpolation, and then you can change the settings for it. And you've got amplitude and period. And the period is the one that's going to make the biggest difference first. Right now, the period is 1 second, and our animation is only 1 second, so it's not going to do anything. But if I set it to 0.25, that's going to give me 4 oscillations in that same time period. So now you automatically get something like that. And with the low frame rate, it does create this really kind of interesting jerky movement. And so what I want to do is right at the end of this animation, right before it stops moving, I want to make Face Punch's opacity go back to 0. And I want to turn the rest of these back up to 100%. So we bring back the normal Joey. Now, if I just play this, you're going to see we're going to have an issue because we have a fade on this. That's not what we want. I need these opacity keyframes to be hold keyframes so they don't interpolate. And I need to make sure that my opacity keyframes on the Face Punch layer are also hold keyframes. So now we get that. And that's going to be pretty cool. And I thought there was one other little detail that might be fun. It might be fun to play a little sound effect when this triggers. So how do we do sound effects in Rive? Adding sound effects in Rive is super fun. You're going to have a lot of fun playing with it. It's almost addictive because you're basically creating your own little sound machine when you do it. You just got to keep in mind that it is going to increase your file size if you are embedding the MP3 or AIF or WAV file in your Rive file. And when you get more advanced with Rive, you can actually host these files separately so they can be kind of loaded right when they need to be or in the background. That's up to the developer. But for most motion designers who are not developers, you're going to be embedding everything in the Rive file. So just keep that in mind. You don't want your Rive file to be too big where someone's sitting there waiting forever for it to load. So adding audio in Rive is actually pretty straightforward. What we're going to do is go to Assets, and I'm going to import 2 audio files. I grabbed 2 MP3s, one for being hit in the gut, one for being hit in the face. So I'll bring those in. And then I'm going to go back into design mode, and you can just drag both of these audio files onto the canvas like this. And now you have them available to be triggered in the timeline. And let me rename these so they're a little bit easier to find when we need them. So gut sound effects and face sound effects. And now to trigger that sound effect on this first frame, all we need to do is select the sound effect, come over to its properties, and there's a little keyframe indicator for play audio, and that adds that keyframe to the timeline, and now the audio will play. You get major props if you post a comment telling me where that sound effect is from. And now this animation's pretty much good to go. And you got to admit, you're going to want to click that a lot. Now let's set up the gut punch. So I'm going to right click the Face Punch timeline, duplicate it, and we'll call this one gut punch. And it's basically already set up for us. All we need to do is replace the sound effect. So let me grab the gut sound effect and add the keyframe. And then instead of showing the Face Punch layer, I'm going to show the gut punch layer. So what I can do is just put a keyframe on gut punch like this. I can just put a keyframe on opacity. Now it shows up on the timeline. Then I can just grab my Face Punch layers, select gut punch, and paste them all. And then I can delete my Face Punch. And so now I've got the same animation on gut punch. Now the problem is you're seeing Face Punch. And the reason for this is a common gotcha in Rive. So if I go back into design mode, you'll see that the Face Punch layer and the gut punch layer, they both have this visibility setting. And if I turn them off, you might think that you've actually turned the opacity to 0, but that's not what's happening. This is really more like the visibility setting in After Effects. So if I want to ensure that gut punch is not visible during the Face Punch timeline, I actually need a keyframe for that. So with gut punch selected, I can just set the opacity to 0. And then I can do the same thing on the gut punch timeline. I can grab the Face Punch layer and set its opacity to 0. And so now we've got gut punch and we've got Face Punch. And if I go to the idle, now you see we have the same issue where we're seeing the Face Punch and the gut punch bodies. No big deal. I can actually just turn those off the same way. I'll select both of them, set their opacity to 0 on the first frame, and now they're gone. So now let's set up the triggers for these punches. So what I'm going to want here, let me turn off the visibility of these so it's a little bit easier. Basically what I want is another hitbox, one for my head area and one for my body area. So the one for my head is going to be pretty easy. I'm going to make a new ellipse, but before I do that, I'm going to turn off the visibility of the mouse tracker because we don't really need to see that anymore. Let me grab my ellipse tool and I'm just going to draw a shape roughly the size of the head. So this is going to be the head hitbox. So I'll type in head hitbox. I'm gonna add that tag to it, the hitbox tag, and I'm gonna delete the fill from it. I gotta leave opacity at 100%, but it does not need a fill. Now I can go back to animate mode, go to my state machine, and turn this into a listener. So I'm gonna add this as a listener, and this is gonna be listening for a different event. This is gonna be listening for the mouse down event. In Rive, you've got a few different events that you can listen for from the user. Mouse move, pointer enter, pointer exit, pointer down, pointer up. And there's also a pointer click event that's relatively new. Pointer down is the moment that you click the mouse. Pointer up is when you release that click. Sometimes you actually want that granular kind of control, like if you're doing a dragging interaction. You want something to happen while the pointer is down, but before the pointer comes up. In this case, I just want to trigger this when the pointer goes down. So in my setting for this listener, I'm gonna change this to pointer down, and then I need something to happen. So what is supposed to happen here? Well, in order to understand that, you gotta understand a little bit more about Rive. One more time, if you're really digging this and you really wanna get good at Rive, check out our Rive Academy Volume 1 and 2 courses on our All Access platform. So what you need to understand is that listeners listen for events from the user. And then you want to trigger different timelines to play based on that. And so what is the thing that tells Rive, okay, now play this timeline, now play this timeline? The things that do that are called conditions, and conditions need inputs to tell them when they have been triggered, okay? So we're gonna need an input, and we're gonna need a condition, and we're gonna set this up on an animation layer. These are all concepts that you'll wrap your head around, especially if you go through Rive Academy, but just playing around with Rive long enough, you'll start to have this stuff click. So let's come over here to the input section, and what we're gonna do is just add a simple input called a trigger. A trigger is an input that you can fire from a listener, and then that can make certain things happen in your state machine. So this is going to be face clicked. And so when that head hitbox detects the mouse down event, what I want it to do is, let me erase this default behavior here and add a new one. I want it to change an input. And the input I want it to change is face clicked. It's going to fire face clicked. And basically, it's just going to activate this, and then that's it. And I can activate it as many times as I want. But nothing will happen because this isn't wired up into anything yet. So I'm gonna need a state machine setup that actually responds to this input. So here's our state machine. Currently, we only have one animation layer. It's called layer 1. So let's call this idle because this is the idle state machine layer here. And I'm gonna add a new layer, and this is gonna be called face punch. And the cool thing about Rive is you can have multiple timelines playing at the same time. And it makes it a lot cleaner, so I don't have to have a really crazy state machine setup here. I can just make a new layer. I can drag my face punch timeline to it, and then I can tell Rive what condition needs to be met to play the face punch animation. Now, there is something I'm gonna need to do first before I tell Rive to go to this face punch animation. I need basically like a holding room for Rive to chill in until we actually click the face. And so I'm gonna make a new timeline, and I'm just gonna call this empty. Empty doesn't need any keyframes in it. At least I don't think it does. So we'll find out once we run the state machine. But it's basically just a place for Rive's state machine to sit while it waits for this face clicked input to be fired. So what's gonna happen is when we start the Rive file, we're gonna go from entry into empty, okay? With no conditions, it's just gonna go right there. Then I wanna go into the face punch timeline and play that silly animation only when this condition is met. And if I right click on the condition, I wanna listen for the face clicked input, okay? So once that happens, what happens next? Well, once the face punch animation is done, I wanna go back into this empty holding room. So I need to set something on this condition to tell Rive, you need to wait until face punch is 100% done playing and then go back to empty. The way you do that is you turn on exit time and you set it to 100%, just like that. So now if I play the state machine and I click on the head, we have an issue. So what's going on here? What's going on is I still have face punch and gut punch's visibility turned off because in design mode, they're kind of distracting. But I do need them to be on when the state machine is running so that I can actually see those layers when they're supposed to be triggered. So let me click, and there's my animation. Now this works pretty great. However, if I click in the middle of this animation, it doesn't play. I have to wait until it's completely done before I can click again. And so there's a couple of things that are just kind of best practices. The first thing is my face punch timeline is longer than it needs to be. It really ends right here at 1 second. So I'm gonna set the duration to 1 second, and I should do the same thing on the gut punch so that we don't have extra time where nothing's happening. Then in my state machine, I really need to think through all of the possibilities here. So if we're in this waiting room and the user clicks, it should play face punch. But what happens if in the middle of face punch the user clicks? What should happen? Well, I want it to just play face punch again, right from the beginning. So there's a neat little trick that I like to do here. I'm gonna grab this empty waiting room timeline and I'm gonna have another copy of it here. And I want face punch to go to that if, while this is playing, that face clicked input gets clicked. And then I want immediately to go back to face punch. So what's gonna happen is if this is playing and this condition is detected, Rive is gonna go to empty and instantly turn around and go back to face punch. And the user won't even notice it, but it's gonna make it so we can click face punch over and over and over and over again and keep playing with it. So watch this now. Perfect. So now that animation is all set up. How do we set up gut punch? Well, the good thing is, because we already did all of this work, it's gonna be really easy to set up gut punch. First, we are gonna need a hitbox for it. So let me turn off the visibility on these for a minute. And I'm gonna grab my pen tool and I'm gonna just draw a rough shape, basically where the user should be able to click to trigger that animation. And this can be fairly rough. There we go. So this custom shape can also be a hitbox. Let me rename this gut hitbox, and we'll add that tag. And then we can turn off the fill. We can just delete it. We'll go into the state machine, and we can set this up as a listener. So we're gonna need an input for that. So let's just go ahead and add that. So we've got gut clicked, and then we'll need the listener. So we have gut hitbox selected. We'll add it as a listener, and we'll again be listening for the mouse down event or pointer down event. So let me set that up. I'll get rid of the default behavior and I'll add instead input change, fire the gut clicked input. And now we can create a new layer for the gut punch. And because I have all this set up, I can just right click the face punch layer, duplicate it. I can rename this one gut punch. And now I can just replace this face punch timeline with the gut punch timeline by dragging and dropping it like that. And then I can just update the conditions. I'm not listening for face clicked, I'm listening for gut clicked. And same thing on this condition. I just need to change those two things. I need to make sure gut punch and face punch visibility turned on. And now I can click the head or I can click the gut. Love it. All right, let's start to actually integrate this into the design so we can start to get a feel for how it's actually gonna look. So here's our Joey artboard with all that work done to it. And then up here, we've got our primary artboard. So the first thing is I need to bring in that circle from Figma. This circle is just a shape in Figma with a dithering layer over it to create this kind of 8-bit look. And so I'm just gonna export this out as a PNG. So I can just have this group selected and I can come down here to my export options in Figma, and I've already set this up. So let me erase this to show you how to set up exporting in Figma. You can click any layer or group of layers you want and add an export to it. And then you have all these great options. I'm gonna leave the resolution at 1x because if I set it to 2x, I will have more resolution, but I don't need that resolution and it's gonna make my file bigger. I do need this to be a PNG because that dithering pattern is a raster piece of artwork, so SVG won't work, but PNG is fine. And then I'm gonna export this, and I could just save this as circle.png. And back in Rive, I can just bring that in with my assets panel. And I'll drag that right onto this artboard. I'll center it and bring it right down to the bottom. And now that's good to go. Now I can bring in Joey. So what we need to do is add what's called a nested artboard. So I can grab the nest artboard tool, click anywhere in here, and it's gonna ask me which artboard are you trying to bring in? And I wanna bring in Joey. So this is the full artboard that we have down here. You can think of nested artboards like a pre-comp, except all the interactivity comes along for the ride. It's pretty cool. Now I wanna make sure that this is positioned right. So let me go back into Figma. And I can see that the top of the circle basically is right under my nose, and I can kind of see where the jeans are cut off. And so let's just mimic that in Rive. And first, I need to turn off this background because I shouldn't have this background visible in this main artboard. So I'm gonna right click on the nested artboard and say go to artboard. And then I can just remove this fill from it. I can turn off gut punch and face punch temporarily, so it's a little bit easier to see. And because I'm in design mode, I can also go into my head solo and I can tell it to use the primary kind of looking right at you head, which is going to make it a little bit easier to mimic the design. Now I can come back up here and zoom in, and I can move this to right about where it's supposed to be, which is right about there. And on this artboard, if I select it, I do want it to clip. I don't want to see the legs. So I'm going to turn on this option, and now I don't see the legs anymore. Now, if I go into animate mode and I play the state machine, you'll see that I've got my character inside of this website. And if I click, because I turned off those layers and didn't turn them back on. So I do need to do that. But the animations are working and the mouse movement is tracking. So I can just right click that artboard, go to artboard, and I can just turn those back on so that those will work correctly. And then just to double check, I'll click on this artboard, animate mode, we'll play it, and we'll test this out. Excellent. So this is looking great, but now I want to get a little bit fancy. So I want a slightly more advanced behavior here. When the user gets to this website, they're going to be moving their mouse, and Joey is going to be looking at the mouse, but I kind of like the way it looks when Joey's looking right at you. And so I don't really want his head to start moving unless the mouse gets within a certain distance. And then once it's in there, I want him to follow the mouse around until it leaves that area, but not right away. When it leaves the area, maybe it follows it for another second or two before turning back to the camera. So that way, when the mouse is far away from Joey, Joey's looking right at you. But as it gets closer, now he starts to track the mouse. So now we're getting a little bit more interesting behavior that's gonna help us keep our design a little more consistent, but it's also gonna be kind of cool. Now, how are we gonna do that? All right, so this is gonna get a little fancy here. This is gonna be fun. Here's what we're gonna do. What we're gonna need to do is use constraints in a little bit more of an advanced way. So let's just recap what we've got going on here. We have the mouse tracker layer, which I've turned off. I'm gonna turn it back on for a minute, and I'm gonna move it way up to the top so you can see it. Inside of that mouse tracker, we've got the mouse offset layer, which is what's actually controlling the joystick here. And so the way this is currently set up is that this mouse offset, which is the layer that is controlling the joystick, remember, that's what we set as the control source, that is always on. But what if we want it off sometimes? How could we do that? All right, so here's what we're gonna do. We're gonna create yet another little circle, and I'm gonna call this Joystick Center, like this. And I'm just gonna position this guy right in the center of this joystick, and it is not going to move. It's just going to stay there, okay? So this is going to be a mouse anchor. I'll lock it so it doesn't move. So now we have a layer that tells us where the center of the joystick is, and that is where we want the joystick control when the character is supposed to be looking forward. Let me turn off these layers temporarily so we can see this. Now, right now, I've got the mouse offset, which is the layer actually controlling the joystick while the mouse is moving. I've got it inside of the mouse tracker, but I don't have to do that. I can pull it out, and instead of parenting it, I could put a constraint on this. You've already seen me do this. So what I want to do is take my mouse tracker, and I want to put it right in the middle of my character's face. I want the mouse offset to be constrained to the mouse tracker. So I'm going to add a constraint. We're going to use that same translation constraint, and I'm going to turn on the offset so that it doesn't jump to the mouse tracker's position, but it stays where it is and just kind of moves like the mouse tracker. And then I can choose the target as the mouse tracker. So now we're going to get the same behavior we had before. If I play the state machine, you'll see that with that constraint enabled on the mouse offset, it behaves exactly like it did before. But here's the cool thing. Now, because I have the mouse offset parented to mouse tracker with a constraint, I can keyframe the strength of that constraint. So what I want to do here is, let me rename this constraint. So this is a translation constraint, but I'm going to rename this mouse position. Then I'm going to add another constraint. Translation, so same kind. I'm going to not turn on offset, and I'm going to target the joystick center. And then I'm going to call this one Joystick Center. Now, inside of the translation constraint, you've got a strength parameter that you can keyframe. So this is what's cool about this. I'm going to make a new timeline. And actually, first I'm going to make a new folder, and we're going to call this Joystick Activation, because this is what we're really dealing with here. And we're going to have two states. So the first state is going to be not active. And when the joystick is not active, basically this mouse offset, I don't want it to be tracking the mouse tracker. I want it to be tracking the joystick center. And so what I can do is I can keyframe the strength of these constraints. So when it's not tracking the mouse, it should be 100% on the joystick center, and it should be 0% on the mouse position. And so now we've got keyframes for that on that timeline. Then I'm going to duplicate this timeline, and I'm going to call this active. And here I'm going to want the opposite. So when we are tracking the mouse, I want the mouse position strength 100. And I want the joystick center strength to be 0. Great. So now we need to add a state machine layer to control this. And we need to think about how we want this to work. So we've got this hitbox, this massive hitbox, and this can track our mouse all over the website. But I don't want it to activate the tracking until we get maybe within an area like this. So I'm gonna need yet another hitbox, and so I'll draw something, I don't know, maybe something around here maybe? Maybe we include the entire character just so that if the mouse is down by his legs, you could assume that he should be looking at it. So maybe something like this. And we're gonna call this hitbox activate. Let's tag it, and let's turn off the fill, and let's center it. Okay, cool. So this is going to turn into a listener. So we're gonna go to our state machine, we're gonna turn it into a listener, and we're gonna need to listen for a couple of things. First, we're gonna need to know when the pointer has entered this hitbox, because that's when we're gonna activate the mouse tracking. I'm gonna make a new layer here, and I'm gonna call this activation. Now, when that hitbox activate here's the pointer enter event, that means the mouse comes into it. That's when I want to turn on the mouse tracking, and we're going to need an input for that. So I'm going to create a new input that is a Boolean. A Boolean input is something that just has two options, yes or no, on or off. The trigger input that we used before, that is something that fires, and you can fire it over and over again, but a Boolean basically goes back and forth. So I'm gonna use it to know, is the mouse inside of the activation area or is it outside of it? So we'll say mouse activate, and by default, it's gonna be off, but when the pointer enters, it should turn on. So I'm gonna come here to this listener, and I'm gonna delete the default behavior, and I'm gonna say change input, mouse activate set to true. And so now watch over here when I run the state machine and I hover over this with my mouse, mouse activate turns to true. Now that I have an input, I can trigger things in my state machine. So when the state machine starts, I first don't want mouse tracking to be active. So I'm gonna go directly into the not active timeline. And then I've got the active timeline, and I can go into that when a condition is met. Which condition? Well, I'm waiting for mouse activate to be true. Perfect. And we'll stay in this timeline until mouse activate is false. So let me set the reverse condition here. So we can basically just go back and forth between those, okay? But we don't have any way of setting this to be false. So what I need to do is duplicate this listener here that's set to pointer enter. So I can right click and duplicate it. And I can have it also listen for pointer exit. So I'll just change the setting here to pointer exit, and I'll say when that happens, set mouse activate to false. So that will trigger this condition. We'll go back to the not active timeline. So now if I hover over this, you can see that mouse is activated. Cool. And then when I leave, it's not activated, and the head immediately snaps back, okay? Now, this is not exactly what I want. The first thing is I want there to be a little bit of a blend between activated and not activated. So his head doesn't just snap back. It turns back, right? And so the duration is basically the duration of the transition from one timeline to another. So if I set that to, say, half a second, and I can even put an animation curve on there. Now, watch what happens when I play this. If he's looking, let's say, down here, and then I move my mouse outside, you see how now it actually animates back? You can actually see, this is kind of cool because I left the visibility on, you can actually see how that mouse tracker moves back to the center of the joystick. And so his head turns back. Very cool. And that feels a little bit fast. So why don't I tweak those settings? Maybe it needs to take about a second for that to happen. And as the state machine's playing, I can play with this and just keep trying different things and see what happens, right? The next thing is, should that happen instantly as soon as I leave, or should he keep tracking for another second? Well, I can turn on exit time and say, we're gonna wait at least this long before we transition. And so I could set this to 1 second or 1,000 milliseconds. And now when I exit, you can see that it will wait a little bit. Now it's gonna kind of depend where in the timeline it is, how long it actually takes, but you'll see that it's still tracking me even a little bit after the mouse leaves that tracking area. So this is kind of cool because now when the user goes up to the navigation, Joey is no longer tracking the mouse. He's now looking right at you. But when you get close, he does start tracking you, and they track you for a little bit longer, and then he stops. So this is a way more complicated behavior, and we had to do some fancy footwork to get this to work. I love doing this kind of advanced stuff in Rive because it really is kind of like building with Legos. And once you wrap your head around the way it works, you understand inputs and listeners. We haven't even talked about data binding, which is like sorcery and lets you do incredible things. That's a much more advanced feature. But even just using listeners and inputs and conditions and layers and learning how timelines work, they're kind of different in Rive. You can do crazy stuff like this. All right, I'm gonna show you one or two more things before we're gonna call this done. So here's the current state of our artboard. If I move my mouse up here to the navigation, you can see Joey quits tracking me, which is what we wanted. And if we come back around, he starts tracking again, but then I'm about to click on this and he turns back. This is looking really cool. I can punch him in the face. I can hit him in the gut. This is really a lot of fun. So now we need to add those app icons, and I want a little bit of interaction on those, and that's gonna be pretty simple to set up. So back in Figma, I have this design set up, and these are all pretty large icons. I think the actual size is something like 800 by 800. But you can see I've scaled them down to kind of mimic depth, and I've played with their opacity. And I want to minimize the amount of memory these are going to take up in my Rive file. So what I'm going to do is just select all of them here. So I've got all of them selected. I can zoom out. And I'm just gonna copy them over here off the artboard. And what's cool about this is I can export these now, and they will export at the size they actually are. So the Rive icon needs to be a little bit bigger. It's gonna take up a little bit more memory. I'm sure the Rive guys don't mind, but Illustrator is much smaller. It's gonna be a lot smaller file size, but that's okay because it's really small in the composition. So this is about being efficient with your memory usage. So let me click on export. I'm gonna be exporting 6 layers. And I'll make a new folder and I'll just call these icons and export them. Now in Rive, I can go into assets and I can just import all of those. I can grab all of these and just drag them right onto the artboard, and then I can just position them about where they were in the Figma file. So I'll do this really quickly. All right, those are good to go. We can play this in animation mode and run the state machine. You can see they're there. So I want a little bit of movement on them, and I thought it would be kind of cool if they reacted to the mouse movement a little bit. So there's a really neat trick that you can use to kind of fake parallax in Rive. It's pretty cool. So to do this, we're basically gonna recreate the setup that we had in the Joey artboard. I'm gonna draw a really big shape, and this is going to be a hitbox, and we're gonna be able to track the mouse with it. So I'll just tag that. We're gonna remove the fill. I'm gonna go into the state machine and set up a listener for that layer, and we're gonna be listening for the pointer move event. So let me set that up. And then we're just gonna need a layer to act as the mouse tracker. So we'll make a little circle. We'll name this mouse tracker, and we'll tag that so it's easy to see. And then on this listener, I can just tell it that the behavior I want is to align the target mouse tracker. And so now we've got that layer tracking the mouse. Beautiful. Then what we can do is we can set up all of these icons to look at that mouse tracker and move accordingly. So check this out. If I select the Rive layer and I add that same translation constraint to it, and I tell it that the target is the mouse tracker, when I start playing this state machine, that Rive icon is now stuck to my mouse, okay? Pretty cool, but not what I want. But what's really neat about this is if I grab that Rive layer and I go into the constraint, I can set the strength really low. Like let's set it to 5%. And so now it's pretty much back where it started, but it's going to move just like my mouse, but only 5% as much. Now, what's really neat about this is if I do the exact same thing on the Photoshop layer. So let's set up a translation constraint and let's target the mouse tracker. But let's set this one to maybe 2% because it's further away. Now, Rive is moving more than Photoshop, but they're both kind of moving the same way. And maybe it would work even better if it was lower than 2%. Maybe it's just 1%. Right? And you can see how we're starting to get this fake parallax. So I'm going to quickly go through and set this up on all the other icons. The ones that are closer will have a higher percentage. The ones in the back will have a lower percentage. So those are all set up, and you can see it just gives you a little bit of parallax. Nothing crazy, but, you know, just a little extra something. Let me turn off the visibility on the mouse tracker and just check this one more time. And this is pretty great. Now, there's a tiny little thing that I'm noticing. So if my mouse is over here and I start the state machine, everything looks good. But when I move my mouse, everything jumps. Why is that happening? This is just troubleshooting in Rive. Happens all the time. So basically what's happening is those icons are where their initial position is when the state machine starts, because the mouse has not yet moved. As soon as it moved, it triggered the listener, which updated the constraints, and everything jumped. And from that point on, everything moves smoothly, but that initial jump is annoying. So how can we fix that? Well, the easy thing would be to just have those icons kind of scale up from 0 so they're invisible until the mouse moves. I think it's a simple solve. So what I'm going to do here is on this timeline for this artboard, I'm going to name this intro. And we can do a few things here actually. So why don't we first put a little scale up on all of these icons. So I'm going to make sure my scale X and Y are locked together. I'm going to put keyframes here so they're at 100%. And then I'm going to move this down just a few frames, maybe 10 frames. This timeline is currently running at 60. And I don't know, it might be cool to try doing this at 12 too. So I'll set that to quantize at 12. And then on the first frame, I'm going to set all of these to 0. And what's cool is I can just select all of these. And let me move these keyframes a little bit further apart here. And what's cool is I can select all of these, so they're going from 0 to 100, but I can use that elastic interpolation. And I don't know, maybe I set a period of 0.5, and now you're gonna get this instant little easy kind of scale up with a little bounce to it, which is kind of cool. Let me make this timeline a little bit longer. Let's make it 3 seconds. And then we can just kind of offset these randomly so that you get a little bit more randomness to the way they kind of appear, right? I think it'll just be a little bit more interesting. So I'm basically just kind of messing around with the timing of these. There's no rhyme or reason to it. And so now it looks like this. Much better. So this is something I want to trigger. I'm going to call this icons intro because this is going to be separate from any other intro animation we do. So now we need our state machine to be able to trigger this. And so what I need to happen is when the state machine starts, I need those icons to be invisible. So let's duplicate this timeline and we're going to say icons disabled. And what we're going to do is just get rid of all of the keyframes other than the ones where they're set to 0. And just to clean this up, we can line them up on the first frame. It doesn't really matter, but just for my OCD. There we go. All right, so what I want to happen is when we start the state machine, we're going to start in the timeline where the icons are disabled. So they're just not visible at all. Then we're going to go to the icons intro, but we're only going to do that after the mouse has moved. So in order to do that, we're going to need an input. So I'm going to add another Boolean input, and I'm just going to name it mouse has moved. All we need to do is listen for this once and then activate the icons. And that way we won't have that weird little jump. So what I can do is I can tell this listener, hey, right now, when you detect that the mouse has moved, you're aligning the mouse tracker. In addition to that, I also want you to change an input for me. I want you to change mouse has moved to true. This only has to happen once because after that, the icons will just be on screen. So now I can set the condition to go from no icons to icons. Mouse has moved is true. And that is it. So when I start playing this, there's no mouse movement detected, but the second I move my mouse over this, it's gonna fire that input, it's gonna change it to true, and now I'm not gonna get that weird jump anymore. So I'm just gonna move my mouse up here and play it, and I'm not touching my mouse. And the second I move it, all of the icons appear, and it's smooth, and I don't get that weird jump, and I can still click and punch myself in the face. Let me rename this layer. This is the icons layer. And I'm gonna make one more layer, and this is just gonna be like the master intro, just so we can kind of preview some other cool things that we could do. So I'm gonna make one more timeline, and this is just gonna be the master intro timeline. And all I'm gonna do on this one is I'm gonna bring Joey in from the bottom. So I'll grab the nested artboard. I wanna make sure that I'm working at 12 frames per second because I really like the way that that is looking. I'm gonna give myself 2 seconds so I have a little more time here. And then I can grab my Joey nested artboard. I can put a keyframe on Y position, move it forward a little bit, and then bring myself down until I am out of the frame, like this. And then, because it's worked so well, why don't we use the elastic interpolation? Why don't we try 0.5? And let's just play that. All right, that's a little bit fast, so I can just move that keyframe further away. That works pretty well. So now I get this nice little entry, which is pretty cool. And then the icons will activate. So I need another layer for this, right? So in my state machine, we've got the master intro layer. I'll just drag this right in. This just plays right off the bat. And if I play this, there's the intro animation. When the mouse movement is detected, all the icons appear. Joey is tracking me. The idle animation is looping. We can click the head. We can click the gut. This is pretty cool. And all of this type stuff, you could animate that if you wanted in Rive, although I suspect it might be better to do that in Framer or Webflow or whatever web tool you're using so that it's easy to update, easy to change. But even in those tools, you have animation ability, so you can still do a lot of cool stuff. But to do this kind of interaction in any tool but Rive is very, very difficult, and hopefully this is getting you pretty excited. I knew this tutorial was going to be long, but hopefully if you stuck all the way through it, hopefully you learned a ton. Your brain is just crammed with new Rive information. And my main goal was just to get you excited about this tool. I've said this a lot on this channel that Rive, to me anyway, is the most exciting new animation tool of the last decade. I think it is the spiritual successor to Flash. When you wrap your head around it, there is a learning curve with the state machine and the inputs and all the interactive stuff. But when you get your head around it, you have wizard-like power to do really cool stuff like this. And I think that updating your portfolio to showcase some of this and make it a little more fun when you land on it, it's a really good use case for Rive because the clients that come to your website are going to wonder how the heck you did it. Maybe they can do that for me. And if you want to dig deeper into Rive or any other designer animation or 3D topic, please check out School of Motion's All Access program. We have Rive Academy Volume 1 and 2. It's about 18 hours of Rive training. It gets really into the weeds. There are projects you can complete for critique and feedback, and you can get verified credentials should you complete those courses. And they are, in my opinion, I am biased, but in my opinion, the best way to learn Rive. But hopefully you learned a lot in this video. Hopefully you enjoyed it. Please leave a comment below. Let me know if you know where those sound effects came from, by the way. I wonder how many people are old enough to recognize those sounds. They are ingrained in my brain. Subscribe to this channel so you don't miss any of the great content we put out, including Motion Mondays, our weekly news show, and I'll catch you on the next one.